Happy Tuesday evening. Heads up. Microphone died. So I'm using the built-in microphone now. So we'll see how that works.
How is that different from the regular microphone?
Quality's better, and it can make it louder. But I used to have the camera in the back, so I actually don't know if I need it.
Okay.
So we'll see. See how this works. I don't have a choice because it's dead. This works fine. I don't have to worry about plugging it in. Today, we're looking at two things. Surfaces in space, which I'm not going to do any problems on. And what is, in my opinion, the most important topic for when we move on to multiple integration: cylindrical and spherical coordinate systems. Surfaces in space, we're going to start by examining a cylinder. What's a cylinder? So, who can draw one? What does it look like?
A circular cross section. It sounds and I think that's probably what most people picture when somebody says cylinder, right?
So something like that. Stop some drawing.
Yeah.
So if I were just to use the term cylinder, that's what you think of, right? That, what if I told you, was just a special case of a cylinder? Buttering up is not going to get here. Oh, by the way, you're a physics major.
Yes, I am. I was waiting.
I know what you're Oh, you have no idea what you're in for. When do you take your first junior level physics course?
To this semester on the transfer.
You're in analytical mechanics?
I did not take any. No, I didn't.
What are you in this semester?
Huh?
What are you in this semester then?
I mean, this is my first semester, and I'm technically a junior, so that's what I was thinking.
Junior level means level 300 or higher.
Oh, I might take a sec. I don't know, maybe next year.
Surprised. Surprised you should be taking it this year. Although if you're taking Calc 3 this year, yeah.
I agree to take it.
So you have to take linear algebra and difference equations yet.
I'm taking the algebra now, differential equations.
Yeah, which means you won't take your first upper level physics course until next year, next fall. Wonder if that's going to be analytical mechanics or quantum that they offer, because they rotate it. Either way, just wait. So specifically, this type of cylinder is known as a right circular cylinder. Here's the definition of a cylinder. A set of lines parallel to a given line passing through a given curve. It's known as a cylindrical surface or just simply a cylinder. The parallel lines are called rulings. Those windows do not open. I see you eyeing me. As a physics major, yeah, no. Those windows don't open, so you can't jump out of them. That's also why the physics department is on the first floor of science hall, and not the third. I think biology is the third. Chemistry is the second, so if it blows up, it just destroys the entire building.
Please see what happens to us together.
Yeah, they planned ahead. So again, here's a cylinder, right circular, very common. Right? You look at that and you immediately think cylinder. Here's a cylinder.
In the left picture are what we call the rulings
are they circles or are they the vertical lines?
They do the verticals.
Okay, thank you.
Circles can't be parallel. And they're also not lines.
Okay, so the verticals are the ones that are not the, like, or, I'm sorry, the rulings are the ones that are not the,
They'd be the parallel lines.
okay,
Right, in this case, they'd be parallel to the z-axis.
yeah.
Right, so that's where all they're going to be parallel to. Obviously, there's a right circular cylinder that would be turned vertically. Here's another cylinder that you may not look at as a cylinder. Here's a cylinder. Quadric surface. Any surface that can be represented with that relation. So a three-dimensional quadratic equation. Depending on your Calc 2, you may have studied conic sections. This is the three-dimensional equivalent. Conic sections are quadratics in two variables, x and y. Quadric surfaces are quadratics in three variables, x, y, and z. That would be its general form. And there are several special quadric surfaces that are studied. First up is an ellipsoid. And these slides will be posted. So I recommend just going on and printing out the slides that have the information that you need. Is a sphere an ellipsoid? Yes. Is a special ellipsoid where your A, B, and C's are all equal. Just like a circle is a special ellipse. A circle is an ellipse where the semi-minor and semi-major are the same.
Semi-minor.
And semi-major.
Why do we say semi-minor and major? Semi.
The semi,
That's just what they call it.
the semi is half the diameter, so like just the major is the long diameter.
Okay, so it's the same as say the minor and major axes, right? Okay,
I've never used major minors, always been semis
okay.
that I've used.
Thank you.
A paraboloid of one sheet. Notice here the axis is the axis that corresponds to the negative variable. So the one that's drawn has a z-axis. put two sheets. In this case, the axis is the axis that corresponds to the positive variable. Those three all had relations equal to 1. An elliptic cone. The only difference between this and the hyperboloid of one sheet is this relation equals 0. An elliptic cone equals 0, not 1. We have an elliptic paraboloid. The axis is the axis that corresponds to the variable that has a first power. And then a hyperbolic paraboloid. Again, the axis is the axis corresponding to the variable to the first power. Those are not the only quadric surfaces, those are just the 6 most common. I believe the lecture video does, there were some problems with these, how to recognize them. Yeah. I'm not going to spend any more class time on. I don't see them as that important. Here is where it gets important. Especially in physics. Not this one per se, but spherical. It's very important in physics. Cylindrical coordinate system. Remember polars? Oh, you're not going to have a fun time.
I'm refreshing myself every day. I'll get there soon.
May want to. Cylindrical is just an extension of polar into the third dimension. That's all it is. So in a cylindrical coordinate system, a point in space is represented by the ordered triple R theta z. The ordered pair R theta are the polar coordinates of the point's projection on the xy plane, and z is just the standard z coordinate in Cartesian or rectangular. So, in polar, what is R?
Distance from origin.
To what? R is just the distance from the origin to the point. Do you know what it's called? R. You're close with radius. The radial coordinate, which means you have an R axis, your radial axis in polar. What is theta in polar? Okay, how's the angle being measured? Oh dear. You're a physics major.
Is it called the radial?
Which x-axis?
I mean, probably from where the point is to,
The positive x-axis?
So positive x-axis, yes. Right, there are two x-axes, the positive and the negative. So you always measure from the positive. But how are you measuring the angle? From the positive axis to what? Can't measure it to a point. The point doesn't have an angle.
The line between the point and the origin.
The line segment OP. That is called your angular coordinate. Okay, so in polar, you would then have an angular axis. And Z is just Z, it's the height. It's the height the point is off of the XY plane. That's shown here. Slither of Thorn. So this is probably going to serve as a warning. Spherical is my favorite coordinate system. Unfortunately for you, that comes from my physics background. Spherical coordinate system. So the Cartesian coordinate system, right? You're all familiar with that. The x, y, and z axes. However, it's flat. Flat. Right, so that table, it's three-dimensional, but it's flat. Let's just start simple. The planet we live on, is it flat? See you live. I've disproven the flat Earth is very easily. If the Earth was flat, then cats would have knocked everything off of it long ago. Ergo, we're not flat. Proof complete. The Earth is, I'm not going to say a sphere, because it's not a sphere. It's spherical. It's curved. So shouldn't we be doing everything in a curved coordinate system? It is inaccurate to use Cartesian. Use spherical. So why do we use Cartesian? So why are you using Cartesian coordinates in your intro physics courses?
Because it's simpler.
Well, that's true, but simpler isn't always better. It's pretty much the same reason why in intro mechanics you ignore relativity. It's because over small distances, you can approximate it as flat. So the spherical influence is negligible. Once you start to consider larger distances, you now have to use spherical. Again, we ignore relativistic effects in most mechanics because the speeds at which we're working with are so far below the speed of light, that relativity is negligible. Now move beyond Earth. The fabric of space-time, which is what the universe is on, has been proven to be curved. Which means the universal coordinate system is spherical. And that is how general relativity is done. It's done in spherical coordinates. Even quantum mechanics. Everything's spherical. That's a little backstory of why I love spherical coordinates so much. In the spherical coordinate system, a point in space is once again represented by an ordered triple, but this time the ordered triple is rho, theta, phi. Rho is the distance from the origin to the point. It is once again your radial coordinate. But now we have two angular coordinates. Theta is the same angle as in polar and cylindrical. So what you do is you take the projection of your point onto the xy plane, measure the angle the line segment OP makes with the positive x-axis. That is your theta. Phi is the angle formed from the positive z-axis and the line segment OP. This is known as your angle of declination. Now, in theory, theta can be anything. And again, in theory, phi can be anything. In practice, we restrict them. Also in theory, rho can be negative. But again, in practice, we restrict it to be positive. Right, but theoretically, you can have a negative rho. Theta, what's its restriction? How do you restrict typically theta in polar?
Closest angle between the positive axis and OP.
So what would be the values of theta that you would take?
Positive value, or the anything that's positive or negative between pi and, wait, no, that's not right. I think I know what I mean. I'm just really not going to be able to explain it because I just can't think about it right now.
Between 0 and 2 pi?
Is 0 included?
Yes.
Is 2 pi included?
No.
No. So 0 to 2 pi, not including 2 pi. And the reason for that is because 2 pi and 0 are the same. In practice, you can just take it to be the closed 0 to 2 pi. It doesn't actually change anything. So now I'm going to show you. Wait. Good, the restriction's not on there. So there is a visual representation. So again, in practice, we restrict the values of phi. What do you think we restrict those values to?
Negative pi.
Too large.
Is it between negative pi over 2 and pi over 2?
Right size, but not typically what we use.
Okay.
That's not incorrect.
Pi and negative, or, no, sorry, 0 and pi.
0 to pi. An angle phi between 0 and pi over 2 would represent the point as above the xy plane. An angle between pi over 2 and pi would represent the point being below the xy plane. It being to the left or right of the z-axis does not affect phi. Only its position above or below the xy plane that matters, which is why it's 0 to pi. It's an angle of declination. That angle's the same whether you're to the left or the right of the z-axis. Is pi included? Yes. Is 0 included? Yes. What would an angle of 0 represent? Where's the point located?
On the z-axis.
Which one?
The positive z-axis.
0 would be right on the positive z-axis. And then pi would then, of course, represent what? Point is on the negative z. So there's your spherical coordinates. Now, of course, the burning question in everyone's mind. How do we convert between coordinate systems? Well, cylindrical is simple because it's just polar with the added z equals z. So let's test memory. Polar to rectangular, what were the conversion relations?
X equals r cosine theta, sine. X equals r sine theta, y equals r cosine theta?
Is that your final answer?
Yes.
Exactly.
Okay.
You shouldn't have changed your answer.
All right, that was my mistake.
So you have to think of it in terms of a circle. What's the x coordinate on a circle? Cosine theta.
Y.
X is cosine, y is sine.
X.
So x would be the radius times cosine.
Yes.
Y would be radius times the sine.
Yeah.
So that's why it's x is r cosine, y is r sine.
Right.
And then z equals z. Go the other way. Rectangular to polar. What were the relations? Be careful.
Well, r squared equals x squared plus y squared.
Okay.
And theta involves arctan. Right.
One person in this room makes me very sad right now. Oh wait, no, we never got to this, did we?
No.
Oh, you're lucky. So I retract my statement. Because we had to switch halfway through. Okay, you're lucky. So you definitely want to take the advice that I gave last semester and go over that chapter. Because it's going to be very useful. Depends on the book.
Okay.
They had to use Rogowski, so that's what, chapter 11, I believe, in Rogowski. I think it's chapter 1 in this book.
Yeah.
The volume does tend to use the very last chapter because he's running the first chapter. So I think chapter 1 here goes over conic sections, parametric equations, polar coordinates. So I agree r squared is x squared plus y squared. What's the other relation? Poor.
Do we use cosine?
Tangent of theta is y over x.
Cotangent?
Tangent of theta is y over x. That's the relation.
Okay. And we don't go right to arctangent because of the restriction. All right.
You can't just take the inverse tangent.
All right.
What is the range of inverse tangent?
Well, it's negative pi over 2 to pi over 2. Right?
Which is what quadrants?
First and fourth.
Theta can be in any quadrant. That's the relation. And again, technically speaking, r can be negative, which is why the relation is r squared is x squared plus y squared, and not r equals square root of x squared plus y squared. Because theoretically, you can have a negative r. In practice, you never get a negative r. So in practice, you can just do r as the square root of x squared plus y squared. I don't even know why they allow r to be negative when r is literally defined as the distance from the origin to the point, and a distance is never negative. By the same arguments to why you can have negative time. Yes, negative time is a thing. So is imaginary time, actually, which is really weird. And no, it's not imaginary in that sense. It's time being a complex number. Spherical. X is rho cosine of theta sine of phi. Y is rho sine of theta sine of phi. Z is rho cosine of phi. And I believe I go over a derivation for those in the lecture video. So if you want to see the derivation, watch it. That is spherical to rectangular. To go rectangular to spherical, rho squared, it's a distance, so x squared plus y squared plus z squared. Because theta is the same, its tangent of theta is y over x. Cosine of phi is z over the square root of x squared plus y squared plus z squared, or z over rho. So here's the question. We already know you can't just take the inverse tangent for theta. Can you take the inverse cosine?
Yes,
Why?
because since, alright. Because, I don't have a good answer.
Fixed domain restriction is 0 to 2 pi, which is valid.
Not for inverse cosine. Saw your hand.
I was gonna say, because of the way the formula is written, that no matter what number you choose for z, that kind of matters, it's gonna stay between, it's gonna stay under one, so you can always do it. I don't know how to put it in actual terms, but.
Well, I do agree that's always going to be within the domain of cosine.
So it's always gonna be,
Well, I'm sorry, within the range of cosine.
so it's always gonna be between 0 and pi.
Phi is between 0 and pi, right? What's the range of the inverse cosine function? 0 to pi. So you could just write that. There are conversion factors to go from cylindrical to spherical and spherical to cylindrical. I leave the derivation of them as an exercise. Here we're given a cylindrical point, we're asked to write it into rectangular. X equals our cosine, right? What's R? What is it? What's theta? What is cosine of pi over 3? There's your x coordinate, 3s. Okay, quickly pop quiz. Yes, I'm evil. Right, so y r sine of theta, right? What is sine of pi over 3? Ready? Here's the hardest one. What's Z? Seven. shape. It's not an actual shape. I do have an illegal mic at home. It's only illegal because it's double loaded. There would be the rectangular. Rectangular to cylindrical. R squared is x squared plus y squared. Negative 2 squared plus 2 squared. Real quick, what?
8.
So what is R? Two root 2.
Is that required for tests?
For easy ones like that, yes. Tangent theta is y over x. It's 2 over negative 2. There's a reason I'm going to leave it in that form for now. So look at the points. What quadrant are we in?
The second.
Second quadrant. Y is positive, x is negative. That's quadrant 2. Which means your angle should be between what values?
Pi over 2 and pi.
What kind of value is that going to give? I hope it's not undefined. Well, no. That's what we want. That's not what that is. No.
It'll give you a negative value in the fourth quadrant.
What's the angle?
The angle, well, that will give you a negative angle, right?
Right. So what's the angle?
Oh, a negative radical of 2 over 2.
Not an angle. Hmm?
Oh, I'm sorry, negative pi over 4.
Negative pi over 4.
Sorry.
which is not the angle we're looking for. So how do you get the correct angle that we want? Right, so the question becomes, where does tangent of theta equal negative 1? And you're looking just between 0 and 2 pi. What's the second angle? What's the second quadrant angle?
It's between 0 and pi. I'm sorry, pi over 2 and pi.
What is that angle? So tangent of what angle would be negative 1?
3 pi over 4.
That's one of them. What's the second angle? 7 pi over 4. Right, that's what this question is asking. Right away, you can tell you want 3 pi over 4. I'm showing this work in case you don't get a nice angle. Like, what if that was the inverse tangent of negative 5 instead? That's not a really nice angle. So how would you get from quadrant 4, which is a negative angle, to quadrant 2, which is an angle between pi over 2 and pi?
Subtract pi.
I would agree if I was using 3 pi over 2 to 2 pi, which we're not. Inverse tangent gives you from negative pi over 2 to 0. So that's this. How do you get from negative pi over 4 to 3 pi over 4? Add pi. And geometrically, here's why. That's the angle the inverse tangent gives us. That's the angle we want. What do you know? What's the relation between those two angles, theta and theta prime? What about pi? How would they be related? So what do we know about the line? Well, that's not necessarily negative 1.
Or supplements,
Which means what?
which means they add to equal pi.
Now we have to remember that that theta prime is negative. So technically it'd be the absolute value of theta prime. Right, so again, it just boils down to actually, I think what we can look at is, look at this angle here too. I think what I did is I would do this. If you want to add that angle of theta prime. Right, so some stuff to be pi, so you just pi. Along those lines. That's the geometric interpretation. That's why you just had pi below. Finally, z is z, which is just 3. And so there is our cylindrical point. And I won't make you plot it. Spherical to rectangular. How do we get x?
Rho cos theta sine phi.
What is rho? What is theta? What is phi? What's cosine of pi over 4? What is sine of pi over 6? So what is that? Yes. How do you find the y coordinate? What is it?
Rho sine theta multiplied by sine phi.
What is sine of pi over 4? Oh, well, that's nice. How do we find z?
Rho cos phi.
What is cosine of pi over 6?
3 over 2.
What is z?
Or square root of 3.
Got the blame projector, but it wasn't the projector cutting it off. That's the way I had it zoomed. Rectangular to spherical. What's the first relation?
Rho squared is equal to x squared plus y squared plus z squared.
So what is rho squared? 3. Root 64. Root 64. Or what is rho squared? Oh, 64, sorry.
So what is rho?
8.
Rho 8.
What's the next relation?
Tan theta equals y over x.
Same as with cylinder.
Over 2, 3.
And again, I typically just leave it in that form. And then the theta would be and then decide if I have to add anything to it. What quadrant should theta be in?
First quadrant.
So theta would be between what angles?
0 and pi over 2.
Is that what this inverse tangent gives us? So that given angle between 0 and pi over 2. An area of the triple inside.
Same thing. Does it go around into the fourth quadrant?
The first, right?
That is the first quadrant. That will be between 0 and pi over 2.
Doesn't 3 over root 3 simplify to just root 3?
I could simplify it that way. So I don't need to add anything to it. That was the point of the question. Right, that already gives me the correct angle. Now, what is that angle? Oh, you need a calculator?
Yeah.
That makes me sad. What is the inverse tangent of root 3? Tangent of what angle is root 3? I hope that's one that gives you an approximate, not the exact.
Pi over 6.
Sure about that?
I don't know, I forgot if tan is sine over cosine or cosine over sine. So I'm not sure.
At least she knows one of those. You want to make me half sad.
I agree.
Your answer doesn't count because you cheated.
Mhm.
cosine.
Yeah, okay.
Pi over 3 is theta. Now for theta. What's that relation?
Inverse cosine of z over well, rho. It's rho, right? Get the actual name of the. Yeah, that's right.
That's not the relation I'm going to use. But you're not incorrect. I'm just going to stick with that one for now, because in theoretical purposes, that might be more useful. But what was z? Remember that denominator is rho, so it's rho. Phi is the inverse cosine of -1/2, which is what?
Two pi over 3.
There's our spherical point. Oops. There's our spherical point. Now, let's be real. How often do we care about a single point? Usually we care about a set of points. Usually that set of points is infinite. So really what we're interested in is describing a set of points in these different coordinate systems. Well, whenever you hear set of points, you think immediately relations. Right, so the relation x squared minus y squared equals 25 does describe a set of points. Right, specifically, it's describing the set of points x, y, where x squared minus y squared is 25. We want to describe that in cylindrical. What would x be?
Would be x over 5.
You don't care about that right now.
Okay.
Let's care about what is x in cylindrical.
Or cosine theta.
What is y?
Or sine theta.
What would 25 be in cylindrical?
25.
Just 25. Right, your question's the same. That's a relation. Generally speaking, what they're going to want is something like that. R written as a function of theta and z. So that's what I'm going to try and work towards. How can we simplify cosine squared of theta minus sine squared of theta? Mhm. That's plus. Did one my luck trade. Give me a hint, it's a trig identity. Cosine squared plus sine squared is wrong.
Is it 1 minus 2 sine squared theta?
That is not incorrect. But it's not really simple.
Cosine 2x.
Wrong independent variable.
Cosine 2 theta.
It's cosine of 2 theta. Yes, you're not incorrect. 1 minus 2, right here, 1 minus 2 sine squared or 2 cosine squared minus 1. But they don't really simplify in this case. What does r squared equal? I mean, that's true, but we're trying to write it in cylindrical coordinates.
Like 25 over cosine 2 theta.
Now, why does that make me sad?
Well, it doesn't get us any closer to the cylindrical coordinates we're trying to write.
It does.
Does it?
Particularly it's the form that you gave it to me that makes me sad.
'Cause it could be 0, right?
No, he's right, you divide by cosine.
Um,
Secant!
yeah,
We don't like fractions. Let's get rid of it. So R would be 5 times the square root of secant 2 theta. With no new added restrictions. R squared is positive, right? 25 is positive. That means secant of 2 theta already has to be positive. So you don't have to restrict secant of 2 theta to be positive under the square root because it's already guaranteed to be positive. That's what I mean by no added restrictions. And you already know it can't be 0. Or cosine can't be 0 because then you would have 0 equals 25, which is nonsense. So nothing we did required us to add restrictions to it. So we're done. Rectangular to spherical. That minus c squared. That sucks. That was plus the c squared. This would be really easy. But it's not. What is x? What is it? Wrong coordinate system. What is y? What is z?
Rho cosine phi.
What is 1? Let's just try and simplify it. First two terms have a rho squared sine squared of phi common, factor it out. How does that simplify?
Rho squared theta plus sine squared theta equals 1.
So how does that simplify? How does that first term simplify?
Rho squared times sine squared phi.
By the way, that now derives that relation. That x squared plus y squared in spherical coordinates is rho squared sine squared of phi. That may be useful to have around. Why did I write sine there? And no one called it.
Are you sure it's square that transform? Instead of calling yourself an equation?
Let me do it.
That relation sine equal. And pull P2 out of both of them.
Just call it 8.
It looks like a P.
You just upset every Greek. Actually, we can still use those.
Probably not.
I don't know if they still use that, if that's the ancient Greek alphabet.
Probably, I'm pretty sure they still use it.
No, I'm not sure, but I'm going to look that up. It'd be cool if they still use it. I can simplify. So it's rho squared times something.
Cosine 2 feet.
Negative cosine.
Means that rho squared or rho squared cosine 2 phi is -1. Or rho is the square root of negative secant 2 phi.
And then theta can just be anything.
Yeah, theta winds up being anything.
Okay. When it doesn't, when it,
Yeah, so when you, just like in the previous, z could be anything here.
right.
Because again, generally speaking, what they want is this.
Yes.
They want to try and write it in the form of rho as a function of theta and phi.
Yeah.
Yeah, so if you're trying to describe the set of points, you would then just say theta can be,
Mhm.
again, generally 0 to 2pi, anything between 0 and 2pi.
Right.
Are there any domain restrictions with this?
None that were added.
Okay.
Right, there obviously are, right, you can't have cosine being 0. because then you get 0 equals -1, which is nonsense. And you can't have cosine being positive, which means secant can't be positive. Otherwise, you get rho squared is equal to -1. You get rho squared as a negative, which can't happen. So this in cylindrical. I'm sorry, not cylindrical. I had to read it. Spherical. So what can we do?
Can you figure it out? Like,
Factor what out?
the rho sine thing.
So how's that going to help? If you do that, because you're right, you can, but is that going to help us? We'll work with this. How does that help?
Just factor out rho.
Is there any way to simplify what's inside the parentheses?
Is rho equal to secant theta cosecant phi plus cosecant?
I see what you did and now.
Is sine theta plus cosine theta part of an identity? I can't remember.
There are technically identities I could use. Is it simpler? No. We could use the product to sum identities on the first two terms. Unfortunately, you're going to get four terms out of that, so 2 extra terms with no cancellations. So it's not actually simpler. So no, there's no simplification. So you would wind up with doing this. A whole thing under one.
So in all problems like this, where we start with a relation in one form and they ask us to get it in another form, we basically start by changing the variables and then just trying to simplify and get it as close as we can to what looks like.
Depends on what I'm asking for.
Okay.
You could have just stopped at that very first line, because that is technically a relation in spherical coordinates.
Right.
So you have to be careful and read what it says.
Okay.
A lot of problems may say write it in the form of rho equals f of
Okay.
theta phi, in which case you have to go all the way down to.
Right. Okay.
And division does not distribute across addition, which is why that's not secant theta cosecant phi plus cosecant theta cosecant phi plus secant phi. It has to be left in that form.
So all the questions like this have to be in the form of rho and as a function.
Only if it asks for it.
So it can be another.
If it's just like this, you could stop at the first line. That's a relation in spherical. You're done. But if it says to write it in the form of rho equals f of theta phi, then you have to go all the way down. I did that because a lot of the questions do ask that, so I just wanted to show it.
Will it be in another variable that can like figure out?
It'll always be theta phi if it's. It'll always be rho theta phi if it's spherical, and always r theta c if it's cylindrical. There are other coordinate systems, right? They're not the only two in space. We don't really cover them. And even when we get to multiple integration, we really don't have time to cover the Jacobian, which is essentially the change of variable formula for multiple integration. We can write any coordinate system UV. I might actually assign that as a read on your own kind of assignment. And you have to write a summary on it or something. Haven't decided yet. Because it is useful. How much do I want to do these? Yeah. So convert from cylindrical to rectangular. Again, not entirely useful. Generally speaking, you're not doing that. You're going from rectangular to one of the others. What is R? What is sine of theta?
Y over root x squared plus y squared.
This means that x squared plus y squared equals 2y. Let's get that into a recognizable form. See who remembers how I got that.
You completed the square
Completing the square on
with y.
what's that curve?
It's a circle. Centered at 0, 1 with radius 1.
Circle of radius 1 centered about 0, 1. Oh, wait a minute. This was supposed to be three-dimensional. Which means it's not just a circle.
The cylinder. Z equals all real numbers. Okay.
This would be a cylindrical surface, an infinite cylindrical surface, extending along the z-axis. Right, of radius 1, and the cross section is always centered at 0, 1. So the cylinder itself would be centered at 0, 1. Here we have a bit of an issue. Right, there are two ways to tackle this. The question is, which way do I want to go? And I'll just follow my notes. You could just first try to find out what is rho sine of theta in rectangular. And well, that would be what? Y over sine of theta. And then you have to determine what is sine of theta. Or actually, I'm starting with the multiple. I'm just going to figure out what sine. Multiply both sides by sine of theta first. And then we have to determine what is sine of theta in rectangular. We know what cosine of theta is. just gonna use rho, because I don't feel like writing out the square root of x squared plus y squared plus z squared. We know that phi is between 0 and pi. I think what I'm going to have to do is square both sides to get y squared equals something, for sign to be positive or negative. Which means y can be positive or negative. If you actually do that, sine of theta would be what? Square root of rho squared minus z squared over rho, right? What's rho squared minus z squared? It's just x squared plus y squared, isn't it? That would have to be the relation. Which I have no idea what that looks like.
Homework 4.
That should be what we just did.
Yeah, that's what we're into. So that's the quadrics, and also
And spherical.
okay. Trying to keep up with the lecture.
See you on Thursday.
Thank you. See you.